When thinking of computer programming, one probably thinks of lines and lines of code, oftentimes seeming cryptographic or confusing if they don't regularly work with such. However, long lines of code is not the only part of programming or computer science. Visual programming languages have seen recent popularity as an alternative to the traditional text-based programming. As visual programming languages have developed and improved, they've become an excellent resource to teach computer science at an introductory level, and even teach more complex topics in the field, shifting the focus away from replicating styles of text-based code and towards a look that can teach new programmers about computer science, allowing the focus to be on what's being coded rather than issues with formatting or syntax. The idea of visualizing complex ideas like code isn't new. For engineering, diagramming out something like a circuit is not only extremely useful, but it's often necessary to generalize ideas so that they can be understood clearly by others. Computer science is no stranger to visualizations. The Unified Modeling Language, or UML, is a type of diagramming initially developed as a broad way of visualizing complex ideas in computer science, such as the structure of a database or the layout of a piece of software. UMLs date back to the 1970s when the first programming languages were being developed, and in 1990, UML became standardized. UML and diagramming in general is widespread in the areas of computer science, software engineering, and other fields, iterating with different ways to visualize complex structures even better. With a clear and focused method of representing code, UML has often been the starting point to develop visual programming languages. One such example is a program called Clarity, which utilizes schematic functional programming to implement custom functions for database accesses. Clarity allows users to implement functions in a visual manner. The functions were visualized with lines to indicate data flow, with hexagons used for inputs and outputs, and rectangles for methods that can be performed with and other variables, and the dotted lines were used to indicate network-based running. When Clarity was being developed in the 1980s, it was discovered that visual programming reduced the time to develop complex models specific to databases while also reducing the error rate, but lacking in teaching more complex issues of computer programming, such as handling errors or potentially losing understanding of the procedure at hand if the visual language becomes too complicated. Many other forms of visual programming also developed around the 1990s to 2000s. One such language was made to program the LEGO RCX robotics system. This language utilized colorful blocks to represent different actions or inputs, chained together in an execution sequence. Referred to as iconic programming, this style of visual programming languages was good at making representations of underlying actions, assisting to form a connection between the user and the machine or software, but at the cost of simplifying or modifying complex concepts. LEGO Robotics, with its affordability and customization, sees use in introductory education for robotics and programming to date, with this visual interface having developed with updated styles and additional functionality to control the robots. The development of visual programming languages ties closely with developing software for designing video games. An early visual programming language, Alice, was developed in 1994 as a 3D environment to build games. It features a nested block style visual programming language with function labels similar to text-based languages like Java. It has since been used in some introductory courses for computer programming. While the interface was easy to use, Alice was rather an early adopter of visual programming, so the various crashes and performance issues hindered the engine's ability for more practical uses outside teaching. The software is still being maintained and is open source, so it is easily accessible today to new programmers as a good learning resource. All of the examples of visual programming languages so far have some things in common. For instance, the programmer adds events in a sequence to be called, a common model in most programming languages, visual and text-based. One example of a visual programming that breaks from this common model is ClickTeam's event-based programming, seen in Multimedia Fusion since 1998. Instead of blocks of procedures to call, the event-based programming features a grid of triggers and a series of actions which can be taken for each object placed in a game level. The specific model of a visual programming language is unique to ClickTeam software, and the company continues to develop their game creation software, which some major developers have released successful video games with. The use of visual programming languages for more complicated scenarios has been an idea for quite a while. For example, numerous plugins for the Unity game engine have been made to make more complex code for games or computer graphics simpler to make and easier to understand. In 2012, Epic Games released Unreal Engine 4 featuring the Blueprint visual programming language. Based off the previous engine's Kismet system, the Blueprint system features a wide range of functions to utilize in the form of blocks, with execution flow represented by white lines, and different data types represented by different colored lines connecting to in and out of the function blocks as inputs and outputs. The Blueprint system features advanced aspects of C++, like macros, pass-by reference, and function delegates. The Blueprint system even features nativization into C++ code, and thanks to these advanced features, this visual programming language can and has been used for AAA games, in particular the VR title Robo Recall by Epic Games. While older visual programming languages have seen some success and some issues with being used as a programming language, one language in particular stands out today as a free, accessible, and easy-to-use visual programming language: Scratch. Developed initially by the MIT Media Lab's Lifelong Kindergarten Group, first released in 2007, Scratch has become a great resource to teach simple and even some complex computer science topics and ideas, targeting elementary and middle school students, but accessible online for everyone. The language features blocks with English text explaining the function of the blocks, colored by what type of function the block performs. The blocks snap above or below each other, with loops and if statements encasing the blocks. Function fields are indicated with round or square text boxes, which support dragging user-created variables directly. The interface runs smoothly and overall is styled for kids to easily understand. Scratch is utilized around the world in schools and research. The program has been shown to improve learning concepts in computer science and robotics, as well as motivating new programmers to continue pursuing the field and providing teachers with more confidence to teach programming to new students. Visual programming languages have proven over the course of over 20 years of development that the use of a visual medium can be quite effective at introducing complex computer science ideas and topics in a similar, more attractive way than text-based programming languages, which are filled with syntax and potential errors. Visual programming languages started off based off of UML diagramming, where it was unknown if visual programming languages can be more effective or more confusing than text languages. Older visual languages had older styles, often adding to the confusion or not performing efficiently to be used outside of learning. While some alternate forms of visual languages were formed, generally the languages remained based off of the pattern of sequence of instructions, like most text languages. Over time, visual languages were implemented with more features in a cleaner, more comprehensive way, such that they can be used for final software products. In addition, developing visual programming languages to be more appealing and understanding for kids and new programmers has made teaching, programming, and computer science at an introductory level in schools easier and more frequent than ever. Even today, the majority of visual programming languages, including Scratch, require full desktop to use, with some languages working on mobile apps with less functionality. As visual programming languages develop further, there is without a doubt that they will continue to develop, being more accessible to new and experienced programmers, offering better tools for teaching and developing software, and being able to program regardless of the device used, whether it's on desktop, on mobile, or even in virtual reality.